Right, we're going to try something completely nuts and do this in C Sharp. Um, so this is a similar question to question 100. We're actually going to use some of the same logic that we use there. But this says, given the root of the binary tree, check whether it's a mirror of itself, which is symmetric around its center. So 1, 2, 2, 4, 4, mirror, and then 3 and 3. So it's mirroring itself. If it doesn't mirror itself, obviously it's not true. So um, the number of nodes of the tree is a range of 1 to 1,000, and the values is from negative 200 to 100. Let's just do it recursively, since that's what our other code looked like. So if we want to, we can go back out to a problem list, search for question 100, and we see in my solution that we have a recursive algorithm. So in the same tree, it asks for if P and Q are null, then we'll return true, otherwise we'll return false if one of them are null. And then if P value and Q value is not equal, we'll return false. And then we'll return the recursive step. So what we'll do, we'll go back to that other one, so 101. And what we'll do is we'll do this in C Sharp. So we'll first, what we can do is we can actually put another function in here. So I'm going to do is symmetric for the first function, but I'm also going to do another function that returns a Boolean value, is same tree, which is the same as the other function. So pass in a tree node, that is Q, P or Q. Let's do Q first. And then another tree node that is of type P, that is named P, sorry. I'll have to put one in the next. And then we'll do those same steps in the is same tree from question 100. So if P is null and Q is null, then, let's do it in the same line. We'll return true. If P is equal to null, or Q is equal to null, then we'll return false. And then we'll do another step. If our P dot value is not equal to our Q dot value, then we'll return false. And then we'll do our recursive step. So we'll return is same tree, same tree with our P dot left and Q dot right. So this is a different portion. We have to change this up. So what we're doing is because we're kind of using, essentially the reason we're doing is this same tree is because we can isolate this portion of the tree to its own tree in theory, in some sort of way. So essentially, we're going to make sure that instead of the left and the left are the same, we're going to do the right and the right of this right tree and the left of this left tree is the same, since we're doing mirror. So if Q dot left is equal to Q dot right, and is same tree, and then we'll do P dot right and Q dot left. Okay, put that there, and then all we really need to do here is return is same tree of the root left and the root right, and then the rest of the recursion will take its place. So we're passing the left node and the right node, and then essentially we can go ahead and compare each one of those nodes going down into a recursive step. So we'll run that. Oop, looks like I did something wrong. Sorry, not 2 equals 1 equal. I'm doing it in JavaScript. Okay, looks like it accepted. Submit it. Not submitting. The time complexity of this, since it only has to touch, it's similar to the other question in question 100. Essentially, since it only has to access each node once, it's an O of n solution. So there you go.